So the next one is HTTP, which is Hypertext Transfer Protocol. Let's take a look at what happens in this protocol. It is generally used for browsing. So all your files for the website would be stored on an HTTP server so that clients can connect to that server and then view your website. And that is generally what happens. So the first thing you would do is you as a client would try to connect to the HTTP server by putting in the URL or the domain, which is this, in this case, www.cisco.com. This, again, we know how the DNS works. This is basically this will basically get resolved to the IP address of the HTTP server, and then you would connect to the HTTP server, which would return back to you the code for the website, for the web page that needs to be displayed in HTML format. And once your browser interprets it, you will be able to view the website. Okay. Web server, there are many web servers. There's Apache, there's Microsoft Internet Information Server, many other are available as well. These are generally used to store web objects. What are web objects? Could be HTML documents. These are the web pages. Could be pictures, the images that you have on a website. Video, maybe the videos that you have displayed on the website, and some files that people can download, etc. There, all of these are accessible via URL, the URL that we use to even access the website. You can use all, you can access all these objects through that URL as well. Now you need to complete the packet tracer activity. There's a video I've created that you can follow to complete the activity, or you can follow this particular video here to do the activity. Once you're done, you can come back to this video. So the next one is email services, SMTP and POP protocols. Basically, SMTP and POP protocols are these protocols are how we are able to send emails to one another. There are three email protocols. There is SMTP, which is Simple Mail Transfer Protocol. There is POP or POP3, which is Post Office Protocol, and there is IMAP, which is Internet Message Access Protocol. Now, this one, if I can quickly show you, this one is for sending. These two are for receiving. Okay, we'll take a look at why we have two protocols for receiving and only one for sending, but these are the protocols that are working behind the scenes to deliver and receive emails. Okay, now there's a mail user agent now there's something called a mail user agent, which is nothing but the agent or the device that kind of creates the message or that creates the email. So it's also known as email client here, and it allows messages to be sent and received, and they're placed in the client mailbox. So basically, this is the device, this is the device that allows you to create the emails and send them. And once you receive once you receive the emails on a mail user agent, they're placed in the mailbox. So just like how I mentioned, you send an email using SMTP and you receive email using POP3 or IMAP. So let's take a look at how the email server processes work. The sender and the recipient. So the sender and the recipient both are considered as mail user agents. Okay, they can either be sending the email or they can be the one receiving the email. And once the email is received, it places the email in their mailbox. Now, once you compose an email, what happens is you send that email through SMTP to a mail transfer agent. The email doesn't necessarily directly go to the recipient. It goes to a MTA, which is mail transfer agent, which is nothing but a server that kind of figures out where your recipient basically is. Okay, so it looks at the source and the destination of the email, and it figures out where the email should be sent. Now, let's say in this case, it goes to the first MDA, which is mail transfer agent here, and it doesn't find the recipient on the server. So this particular transfer agent will transfer the email to another server. Okay. And once that server finds the recipient on its list, the email will then be delivered to the recipient's mailbox using the mail delivery agent. So the server that basically places the email in the recipient's mailbox is called the mail delivery agent. And then the recipient will retrieve the message, or the person who is supposed to receive the email, they will open the email either using POP or IMAP. Okay. Now, what is the basic difference before we start the activity? What is the basic difference between POP and IMAP? POP is the short form for post office protocol. Now, what happens in post office protocol is that once the server receives the email, it will store it on the server. But the minute the recipient wants to access the email will be transferred to the recipient, and it will be removed from the server. Okay, so just like when you receive a parcel in the post office, uh, once once it is received at the post office, it stays there, right? But the minute it is delivered to the recipient, it no longer is available in the post office. That's why it's called post office protocol. But for IMAP, what happens is the email always stays on the server. The recipient is just downloading or caching a copy of the email. The email is never removed from the server. That's the difference. In IMAP, the email is never removed from the server. That's why it's called internet message access, because you're just accessing the message, not downloading it fully. But in post office protocol, once you access the message, the email will be removed from the email from the server. Okay. Now you have to implement this activity. Again, you can follow the same video that I've created. The link will be in the description, or you can even follow this video. It's up to you. Okay. Once you're done with the activity, you can come back to this video. Like I said before, email is not, when you're using IMAP, email is not downloaded, but it is always on the server. Any received email is associated with the user's inbox. So anything that you're receiving will be directed to your inbox user. And in IMAP, the thing is you can have multiple folders created on in your email account, and IMAP will always sync those folders as well. But with POP or post office protocol, it only deals with the inbox. It does, if you have other folders, it will never sync those. It will only sync your inbox. But using IMAP, you can also retrieve portions of the email like subject, line, sender, all of that. Web-based email was introduced with Hotmail, so the emails that we usually use now are all web-based. We communicate with a remote mailbox using HTTP, and HTTP is used to push and pull the email. So basically what is happening is that your Google, let's say email, your Gmail is, all your emails are on a remote server, and you are only accessing them using HTTP. And when you're trying to send an email, you're trying to push it. When you're trying to send an email, all you're doing is you're sending the email to the server, and then the server finds where it needs to go next. And when you're pulling the email, that is when you open your account and you want to see your emails, the server will send all the emails to the client. Okay. The next one is file transfer protocol. This is nothing but file transfer. For file transfer, what happens is it was developed again to allow file transfers between client and server. So let's say you build a website, you need to put all the files for that website on a server so that people can access, just like how we discussed the HTTP protocol, right? But how do you send those files from your laptop or your computer to the server? That's where you use a file transfer protocol. It is used to push and pull files from a server running the FTP daemon. So you all you do is you push and you pull files. Push means uh, uploading. You upload files. Pull means you're downloading. So either you're uploading files to the server or you're downloading files from the server, and the server should have FTP enabled on it. Okay. Now, FTP has two ports, port 21 and port 20. Okay. Port 21 is used to establish the connection and transfer of control information. So port 21 basically figures out how to connect the sender and the receiver. Okay. Port 20 is actually the port which sends, the data, the transfer. This is where the file transfer actually happens. Port 21 is just to establish the connection. Okay. So just like here, you have a server and you have a user. The port 21 will be the control port where you establish the connection between the two, and the data port will be the port 20, which is actually where the file transfer is happening. So the client initiates a TCP control connection on port 21. So basically, you try to establish a connection between the client here and the server. And in order to connect to a server which is running FTP, you need to have a username and a password. Just like how for email, if you want to have an email, you need to have an account. Similarly, when you want to access FTP, you need to have an account. This doesn't mean that every computer needs to have an FTP account uh, the for the server. It's just that every user that is using the FTP needs to have an account, okay, or needs to have access to an account. So once the username and password are correct, you're logged in. You'll be able the connection will be set up. And then for each file transfer, TCP opens and closes a data connection on port 20. So the port 20, like we discussed, is the port that actually has transfer, uh, that actually transfers the files, right? So for each file that you're transferring, it will open port 20, and then once it's done transferring, it will close port 20. Okay. Now you need to implement the FTP on the same server that we have in the activity. Again, you can watch this video or watch the video that I have created. The link is in the description, but try to implement this. And once you're done implementing, come back to this video. The next one is Dynamic Host Configuration Protocol, DHCP. Now, the concept of this is that, let's say on a network, you have 400 devices or 400 computers. Um, we know that for each computer to be on a network or for each device to be on a network, it needs to have an IP address. That's how we figure out or find devices. If it doesn't have an IP address, we cannot connect to it, and neither can the device connect to the network. So, but let's say for the 400 PCs that you have on a network, if you had to give an IP address to each one of them manually, it will be a very difficult job because it would be very tricky to remember which IP addresses you've already assigned and which are available. Okay, so you might, like every human being, you might end up making a mistake where where you assign two devices the same IP address, and in that case there would be a conflict, and neither one of them, would be able to properly communicate on the network. So to resolve this issue, uh, a protocol was created which was called Dynamic Host Configuration Protocol. What this does is basically you set the service up on a server. You tell the server that, okay, this is the starting IP address that you can give out, and this is the ending. And these are how many IP addresses you can give out. And the DHCP will automatically assign IP addresses and other parameters like DNS server, default gateway, subnet mask, all of that. It will assign all those details to every device on the network. Now, it is best to keep in mind that the IP that the DHCP assigns is not forever. It is basically assigning IP addresses on a lease. Okay, just like how we have lease that in real life, it assigns IP addresses based on lease. That lease time can be 1 day, can be 2 day, can be 3 days, 4 days, how much ever you decide it to be. Okay, once that lease is about to be expired, the devices would request a renewal. Okay, and then if the renewal happens, is eligible, if the device is eligible for the renewal, then it will again give the IP address to that device for another lease time. Okay, but if in case the device doesn't ask for a renewal, in that case, once the lease is expired, the IP address would be sent back to the DHCP, and then that IP address can be used for any other device that wants to connect to the network. Okay, so IP addresses and other configuration are automatically done. All of these information can be automatically set. IP address, subnet mask, default gateway, domain name, DNS server, etc. All of these you must have seen when you are configuring the PCs and the laptops. You had to manually enter some of them, right? But when you have a DHCP server, you don't have to manually enter that information. You can request that information from the DHCP server. So the DHCP servers can be on a LAN, on a router, or an ISP provider. It can be on anything. It doesn't have to be necessarily a server. It can be a router. The DHCP service can be on a router, on an ISP. Imagine the one that you have at home, the wireless router. It also has IP addresses because it assigns. Sorry, it also has DHCP on it because it assigns IP addresses to all the devices that connect to it, right? So there's a four-step process that takes place when DHCP is working. So the first step is the client basically sends a DHCP discover frame to find a DHCP server. Could be that there are multiple DHCP servers, could be that there are no DHCP servers, you know. So the first thing is that the first thing that needs to the first thing that needs to happen is that the DHCP should be discovered, right? So the client tries to discover the DHCP server. The second thing is that if there is a DHCP server, it would then respond back with an offer. So it would say, okay, here is an IP address that I have available. Here is the lease time that you can have it for. Here is the subnet mask, here is the default gateway, and here is the DNS server. So it's just an offer. It's not accepted yet, but it's offering, the DHCP is offering an IP address to the client. The third step includes requesting. So if the client accepts the request, it would send a DHCP request frame to the DHCP server, letting it know that it has accepted the request from the DHCP server. Okay. At the end, an acknowledgement is sent to the client from the DHCP server. If the offer was valid, it would send an acknowledgement. If the offer was not valid, it would send a negative acknowledgement. So this is what happens. The client first sends a discover frame to the DHCP server. The DHCP server sends an offer to the client. If the client accepts it, it would send a request to the DHCP server, letting it know that it has accepted it. And then the DHCP would then send an acknowledgement. It could be either negative or an acknowledgement, depending on whether the offer is still valid for for the client to have. Now you're supposed to implement DHCP server in the packet tracer activity. You can follow this link or follow this video or the video that I have created. The link is in the description. Now, this one is Server Message Block Protocol, which is SMB. What is SMB? SMB is like a client server file sharing protocol. So you have a client and you have a server. Okay, let's say they're connected together. Basically, SMB is a client server file sharing protocol. So for example, it kind of allows client server communication to happen, and it allows shared access to files, printers, and other resources on a network. So let's say you have a network, and on that you have printer or files that should be shared by all the users. In this case, you would be using SMB for sharing those files and resources on a network. It could be very similar to you in the terms of FTP. You could think that it is similar to FTP because you're sharing files, but it's not just limited to files. It's also uh, it can also share resources on a network, like I mentioned. You can also share printers, and it has a request and response kind of protocol. So the client would request and the server would respond. And the thing is, in FTP, every time you wanted to share files, the port would open and then it would close as soon as you're done sharing files. But here in SMB, what happens is that the connection is long term. It doesn't close, and the clients have the access to the files or the resources that are there on the server as if it is local. So you wouldn't be able to distinguish if so you wouldn't be able to distinguish if the files or the resources you're viewing on your computer are from a server or are on your own computer. There's very little difference that can tell that. This similar this similar protocol on Unix and Linux is called Samba, SAMBA. Okay, just mentioned here. Telnet. Now, for Telnet, like we mentioned before, it is used to access devices remotely. Back in the day, people used to directly connect with devices to access them, right? But now we have a growing need of remotely accessing the systems, the same way that as if we were connected to them directly. This is made possible by Telnet. So Telnet basically allows users to remotely access their device, access another device. So for example, your router or your switch is located somewhere, but you can access but you can access it remotely without being directly connected to it. Okay. A connection using Telnet is called a virtual terminal, VTY, session or connection. So a connection that you establish with using Telnet is usually called virtual terminal. Okay. Telnet uses softwares to create a virtual device that offers the same features as a terminal. So basically, Telnet, just like how you would open CMD, command prompt, or terminal on your computer just to have some direct access to some features on your PC or your computer. The same way, Telnet creates a similar kind of interface for you to connect with the device that you're trying to connect with. Okay, some of the softwares that are used for Telnet are PuTTY, TerraTerm, and HyperTerminal. Usually, this is the most commonly used. Even in the server room, we would use PuTTY. Anyway, but what it does is it creates a similar interface like the one that you have as command prompt or terminal. In the same way, you would be able to type in commands and change some stuff or do something with it. Telnet supports user authentication but does not encrypt data. So in order to communicate with or in order to connect with Telnet, you need to have credentials. If you don't have credentials, then in some cases it won't work. Some cases there are no credentials, in other cases there are, but it doesn't encrypt any data. All data is clear text, like anybody can see it. Okay. And then there is SSH, which is secure shell. It is a protocol that offers secure method for server access. So SSH is, again, it is a way of connecting to the device, but in a secure manner, so that you have a secure connection with your device. Uh, it has SSH has stronger authentication, and it encrypts data, unlike telnet. Okay, and that's it for this chapter. If you have any questions, let me know. The last two, telnet and I think SMB, we won't be doing them in packet tracer. You just need to know the theoretical part of it. But the remaining activities, try to do them in packet tracer. These are really, really important because they will be a part of your exam, also for your project. These are some things that we will definitely configure. So try to do them over and over again so you get the idea and you get into the habit and practice of doing it. And if you have any questions, let me know. Thank you for watching.